We are talking during these days about big data. And big data, everybody is thinking about data and code and programming and applications in the back running. And that we want to transmit today is that data without visualization is not giving real insights. So if you are not using visualization at the end, it is really very difficult to give value to the users. So we are going to see some examples and why. The first thing is why. Well, big data technology is really very, very complex. It's complex to use. And that we are going to see now is what a big data platform looks like. So, well, this is a good example. Big data should be easier to use. So we try to simplify things. And what is that the market is doing and everyone is doing? Well, we are evolving big data with the NoSQL databases and all the unstructured data was a big advantage. But at the end, we realized that everybody was using and was used to program with SQL. So all the platforms in the market have evolved to use or to have a SQL interface on top of the platform. This is the reason why, for example, Spark has this module, Spark SQL, and Hadoop with Hive and all the interfaces. The evolution is go to something very SQL-like, because all the programmers, all the analysts were used to program and to use with SQL. Also, the evolution has gone to use visual tools. And this is something that I wanted to show today. When you install, after you have installed a big data platform, imagine you have 20 nodes and you are installing, and after that, it's like you have nothing. And this is something, well, this is not good at all, because you have installed your platform maybe after 2 months, and you don't have real value from the platform. You need to get insights from the data, reports to analyze, to have something. So the first step is to ingest the data. If you don't have data in your platform, you cannot do anything. After that, you have to make some applications or anything. For that, you need visual tools. And this is something that we are going also to see. What visual tools are we using in the big data platforms right now? And of course, you need to visualize the data in a better way. Why? Because in the big data platforms, you have very big volumes of data, but also relations and data that is moving. The visualization for data that we were using up to big data was not prepared to visualize this in a good way. So we have had to invent new ways to visualize data. We are going to see some examples now. These examples, we started 3 years ago doing this. For example, this one, well, I will put this one. Yeah, this one. As I said, this is 3 years old. And that we are seeing here is in Twitter, the hashtags related with Rajoy in real time. As you can see, well, it is normal to have those hashtags for Rajoy. But as you can see, the way we are visualizing the data is very different to the normal one. Here, this is a very good example because you can see that in Twitter, it is very important to know how the data is moving and how the data is generating. If you don't see the data moving, like in this example, you cannot realize, we are going now to see other example, how data viralize in internet or in the social networks. So we will go to other example. Twitter sample. Here we are seeing how the protests and the people was moving in different cities all around the world using Twitter. So just with the geographical localization of the people, you could see how the people was moving in New York, Barcelona, Madrid, and different cities. And this is other of the visualization tools that we are using more in big data, geographical localizations and maps. This is like a constant in almost any visualization right now in big data. Some of the biggest projects that have been made in Spain are using maps and data localized in those maps. BBVA, Telefónica with Smart Steps, all are using the data localized in maps. We are going to see just one last example. This is something like a classic Neo4j that we did in this example. We crawl the Spanish internet, all the pages or all the websites. It was about 200 million pages, different pages, and we were analyzing all this data, seeing the relations between one page, the links, the comments, processing this with semantic engines to understand what people were saying about other companies. But you could analyze this and to send some alerts and alarms and reports, but you were not seeing the relations between the different web pages. And this was very important. Big data realized this quite a long time ago. So in the NoSQL databases, there are some NoSQL databases that are specialized to allow us to show relations between nodes or between data. And this is that we are going to see now. I think we use a URL that was for Spanish television. This is Neo4j. It is, I think, one of the best for NoSQL databases for relations and graphs. So here, let me show you the sample. This is the Neo4j interface. That you have to do is to load the data there. As I said, we crawl the Spanish internet, so it was a lot of data, but in this example, I think it was only 2 terabytes or something like this. And that you are seeing here, this is the URL for the Spanish television. And we are showing the relations between what pages are linking to that URL. If you are not seeing this in a graphical way, it is really difficult to see what pages are commenting some of the news or the videos that I have in my website. And the good thing about this is that you can create this with Neo4j. Just to put an example, as I said, this is a very classical tool. And you can do this in minutes with terabytes of data. And after this, the result is quite impressive because you can query and see any relation in a graphical way, which is very nice. Imagine to have this in a report. It's completely impossible to follow what are the relations, what pages are linking to me. And as you can see here, you can do any query. So it will move, and you could see anyone that is related to your website. So as I said, these are very classical examples. Why to visualize this in this way? Because everybody, when is talking about big data and visualizations, is talking about geographical localization in maps, which is very nice and has like a wow effect. Things moving, like this one, which is also quite impressive, and relations. But there is more than data visualization for big data platforms and technology right now. And this is that I wanted to show also. So we are going to go to the end of the video. And as you can see, things can go pretty complex. And it is not possible to visualize this without these tools. So we are going now. So not only data visualization. Why? As I said, big data technology is quite complex. Data visualization is very nice, and you need it. But also you need visual tools. Here, this is a very classical example for an analytic platform. The first step is you have the sources, the data, and then, as I said, when you have installed a big data platform, you don't have anything. The first step is to ingest the data. So you take the data from the sources. We start from the left. And then you can ingest the data, but usually you are not going to ingest the data not doing anything. You have to aggregate the data to transform this data. After that, you have the data stored, and then you can start doing something. What? Well, to visualize the data, to make reports, or to make applications ad hoc for that data, to apply matching algorithms, whatever. And this is the part that is in the right. All these visual tools, the dashboards, this is the way to use and to get value from this system. We are going to see what tools are we using in the platforms right now to make all this process. So the first one is to ingest, right? Well, not really. The first one is to install the platform. And at the beginning, when Hadoop started, you had to install Hadoop with commands in a terminal, and this was really very hard to do. But now we have tools to do it. So this is the tool we are using for Spark, for a pure Spark platform. This is a manager for the system, for the cluster. What you have with a big data platform is a cluster with different nodes, from 3, which is a very small big data platform, to thousands or millions of nodes of computers working. So you need something like this to manage the cluster. We are going to see it working. In this example, this one is able to install a big data platform on premise or cloud. So I think it is much better to see it working. We are installing here in Amazon, but you could do it on premise or in a hybrid installation in a private cloud and in a public cloud. But as you can see, this is really easy. I don't know if someone has installed a big data platform here, or, well, it is really, really complex. And to do this with a terminal is even a lot more complex. So, for example, this is quite nice. Here we are installing in 3 nodes, and that you are choosing is what software will go in each node. And here we can see one of the trends that we have right now in big data. I don't know if you are able to read it, yeah? We are installing Spark for processing, but we are installing also Cassandra. And as I said yesterday, combination of big data processing plus NoSQL databases are the best choice right now. And this, of course, make the installation and administration of the clusters even more complex than before. So here, that we are doing is choosing what will be installed in each one of the nodes. Of course, you have Mesos, you have Spark, and you have Cassandra. With Cassandra, you need at least 3. So we will continue. And you can see that it is green. It's green because the configuration is all right. If something goes wrong, imagine you take something and the system will not work, the visual tools will tell you, you cannot do this. This cluster is not going to work. Before, you had to do it with commands in the terminal, and then checking and saying something is not working, what will it be? So we are going to see it in this example. As you can see, drag and drop, just choosing what will go into any node, and there you have done something that was not allowed. So the system is saying what's happening. You can correct it, and then you can go on. Okay. Then this is the first step, to install the platform. With these visual tools, you are installing a platform in 5 minutes. If you have an Amazon account, it is just to download, to install it in minutes. 4 or 5 years ago, when we started, it took us about 1 month to install the first Hadoop version. So you can see how easier it is now and what you can do with these visual tools. We will go now to managing the cluster, because this is also quite complex. So now we have our cluster. It is completely installed. It is up and running. And we want to see if everything is all right. And here you can see these are the nodes in the cluster. And this is one of the trickiest parts in a big data platform. You have several nodes, so you have to be able to see what's happening in each one of these nodes. So the first thing we do in a big data platform, in a big data cluster, is to monitorize the nodes. With this, you can also put alerts to the system. Maybe if the CPU or the memory or the hard disk is getting to some threshold, you will send an alert, and then the system guys will live a lot better. And this is the aim of tools like this one, to help the system people to manage this cluster. With 8 nodes, it is not that difficult. But imagine you have 2,000 nodes or millions of nodes. It is completely impossible to manage a big data cluster without a very good visual tool. So these are the tools that right now we are using. Now we have the cluster running, and we are going to go to the next step, which is ingesting the data. Well, for ingesting the data, in this example that we are going to use is Flume. Flume is like the standard to ingest data in big data platforms, and it was developed for Hadoop. It's part of the Hadoop ecosystem. And that we have done is to improve Flume, because, well, it had some bugs, and also to improve some of the things that Flume had. And also we have integrated Flume with Spark streaming. In this way, you can analyze the data while it is entering in the system. So you can ingest the data and to analyze and to do whatever you want. But also we have integrated Spark streaming with CD. CD is a CEP engine, a complex event processing engine with operations to modify, to analyze the events, and it is able to analyze more than 2 million events per second per node. So it is, with this, we are able to do almost anything. We are going to see it working. Here, well, I will show this one. We are going to start ingesting data. In this example, it is sensors. And with the ingestion and streaming, that we are able to do is to ingest data in the system, see what are the streaming that we are getting. And one of the powerful tools we have is that you can analyze the data that is entering and then transform it and see how the data is getting transformed, or aggregate data, or do whatever you want, and to see it working. In this case, we are using Kibana to monitorize the data, and we are going to see it working right now. Here you can see the cell. In the cell, we are using this cell to see what is the data that is entering in the system that we are ingesting. And while we are seeing the streamings that are going into the system, we are able to create new streams to convert these streams to aggregate data. So imagine that you are using something like a pipeline. Then you have data that is entering, and you are saying, OK, with this data, create this alert. When this data have a threshold above this value, generate an alert. And you can see that in this part. All the alarms are here. Oops. Here in this part. And we can generate new alerts or alarms in real time, just checking the data that is entering in the system. And also you can combine two streamings, aggregating the data, and generate a new stream. How are we doing this? Well, we are using, as I said, Spark streaming, which is incredibly fast. We are using a zip CEP engine, and we are using Kafka. Kafka is the boost, is the magic behind these combinations. With this, you can do whatever you want with the data that you are ingesting. But the good thing is to be able to visualize what's going on, to check it, and after that, OK, I have the data entering in my system, and then I can go to the next step. So, as you can see, this is real time. It is monitoring all the data while it is entering, millions of events per second. So big data visual tools really can analyze almost anything. And we go now to, well. Now we have the big data platform installed. We are managing the cluster. We are ingesting the data. We have transformed the data because we were seeing how the data was entering, and we were able to manipulate and to say, OK, this is the ingestion I wanted, or this is the analysis I wanted to do with the streamings. Now, the next step is to store the data. And as I said at the beginning, and I said yesterday, and I will say next year also, the best way to do it right now is to combine the classical systems, HDFS, with a NoSQL database. And here, this is that we are doing. That we are doing is using Spark. We have integrated Spark with the NoSQL databases in the market. And here you can see, you can use Cassandra, or MongoDB, or Elasticsearch, or HDFS, or Aerospike, or Neo4j, whatever you want. And the reason is that, as I said at the beginning, the big data was pretty difficult to use, but the people, the companies were already using NoSQL databases because it was like easier way to use big data. So we said, OK, if you have already Cassandra or MongoDB, just install Spark and use it with the data that you already have in Cassandra or Mongo or whatever. This is the reason behind this module. So as I said, you are ingesting the data. You have to choose where to store it. Our recommendation is to store it in HDFS, the raw data, because your system will fail. It will crash someday, maybe in 6 months, or 1 year, or 2 years. So it is better to have the raw data in HDFS, because HDFS is a file system. If your system crashes, you will be able to recover the data from HDFS and to regenerate the NoSQL database. So the recommendation, put the raw data into HDFS, transform it or aggregate or do whatever you want, and part of that data, put it in the NoSQL database. More or less, in a big data, in a big system, 15% of the data will be used frequently, and the rest very seldom. So you will compress 75%, 50% in the HDFS system, and you will put 15% of the data transformed, or, well, the data that you will really use in the NoSQL database. And this is that you can do with this module. We are going to see it working. And also it is quite important, you see the ODBC. In a big data platform, to talk about ODBC is like something from the past, return to the past. So why? Well, ODBC is like the door to the business intelligence applications, to Tableau, ClickView, MicroStrategy. So in a big data platform, you will need, at some time, you will need an ODBC. And we are going also to see the integration. So we are going to see it working. So what visual tools are we using to store and to convert or to see what data is in the system? Because when you have the data or in the system, that you wanted to do is to discover the data. You need a tool to see what is inside. This is the tool that we are seeing now. And well, Paco talked yesterday about the notebooks. All the new platforms are using notebooks. This is a notebook for Spark. And as you can see, it is completely graphical and visual. What are we doing here? We are discovering the data. What is inside my cluster? Because I don't know what is it. It is data entering in the system, and I want to know what is the structure to create new tables, to transform, and to store the data. And this is a discovery tool, and we are using here notebook. What can you do with this type of tools? Well, for example, this is one of the best points about combining big data processing with NoSQL databases. NoSQL databases are quite impressive and are very specialized. So in this example, we are using Cassandra to store this data, this 15% of the data that is going into the system. But Cassandra can store, well, petabytes of information. It is multi-column. But it is, with Cassandra, you cannot do joins. So with a big data processing engine like Spark, which is very fast, with Cassandra, that you are able to do is to make a join. You take the data from Cassandra, you process it with Spark, and then you can do a join to visualize the data and see what's going on here. So in this notebook that we were doing was working with some people in England, checking with the notebook, and you could see what data they were entering in the system, and to make a join to combine data and see the result in these nice graphics. This is a very typical notebook, and as you can see, there is not only visual tools for ingesting, there is also right now visual tools to discover what data you have in your platform. So after this, as you could see in this graphic, we have ingested the data, well, installed, managing the cluster, we have ingested the data, we have the data stored in our NoSQL database and the big data platform. We can analyze and visualize and discover what data is inside. But now you want to show or to give this, to transform this into value for the users. You have several choices here. The first one is to make an application ad hoc. So this is quite easy, but it is a normal way. You have to program and to make the application. And the other one is to integrate a business intelligence tool. And that is the reason that you will find in almost any big data platform and now DBC. And also that we are using right now is dashboard or visual tools to generate pages and dashboards and reports in a visual way. It is something, there are several companies doing this all around the world. One very well known is ClearStory. We are going to see a database tool to generate these dashboards. So you have the data there in your big data platform, and you want to do a dashboard. The first thing is that in order to do this or to use a big data platform, you will need something graphical, nice, and we recommend to use widgets. Widgets using OpenSocial is a standard right now. It is behind is Google and other companies. But the first thing is to incorporate data sources to the database, to the tool that you will use to generate the dashboards and pages. So here we are, first you are saying what data sources you will have, because as I explained, in your big data platform, you could have Cassandra, plus Mongo, plus HDFS, whatever. So you will add data sources to those containers, and after the data sources, you will generate the data views. And the data views is the way to put the data into the widgets. So here you are using just SQL. And this is pretty easy because everybody knows SQL. When you have generated these data views, you can check the result and then to go on and to relate these data views with the widgets. And this is that we are doing right now. We are checking, and at the end, you have your widget up and running, and you can put the widget in a page. And in a dashboard, you can have several pages, and with this, you can do a report or a dashboard in minutes. And everything is visual. We are adding a new page here. Here we are. In a big data system also, there is very important to see how data is evolving through the time. So that these widgets are able to do is snapshots. You can do a snapshot in a big data platform for the data that is stored to be able to recover, just sort of a backup, but also for the data that you want to visualize. In this way, you can define for any widget, okay, I want to make a snapshot every day. And then that widget will store the data and the widget at that day, and then for a year, you can see this in a video moving, how the data was evolving, because in a big data platform, you have a lot of data, but data that is moving. So this is other of the nice features. Oops. Sorry. And of course, you can use this type of graphics and all this. But this is data visualization. It is just, as I started the presentation, ways to visualize data, which are very nice. And of course, they are needed. But to get to this point, you need to install it in an easy way, to store the data in an easy way, to analyze, to discover what data you have in your big data platform in a visual and easy way. And then you can make any application, report, dashboard, whatever you want. So at the end, that we are getting is well, this is an integration with Tableau. This is about the ODBC. With the big data platform, you can integrate with an ODBC, Tableau, ClickView, MicroStrategy, and do any report that you want. And this is something that is also evolving. Tableau and ClickView are new ways to visualize the data, new ways for the business intelligent applications. And they are really growing in the market because they are very easy to use. So when you have your data in your platform, you integrate Tableau, and you start doing reports or analytics or whatever you want. Tableau, ClickView, anyone. This is other sample. Okay. Conclusions. Time to value. This is the key. As I said, when you install a big data platform, you don't have anything. You have to ingest data, to develop, to see what's going on inside, to make the application. The key is to go from months to weeks. We have seen now, in less than 1 hour, how to ingest data, to analyze, to make a dashboard. This is the evolution of the big data platforms. So next year, I would like to say that big data is not complex, that it is very easy to use. With this, you will improve the development, the deployment also, because to deploy a big data platform is not an easy task, and to manage the cluster better, and to have a cost reduction support, and at the end, to have more value, but just in weeks, not in months or years. So this is it. Thank you.